Hello and welcome to In Depth. I'm Teena Jha. India is all set to launch its second lunar mission Chandrayaan II in July this year. According to the Indian Space Research Organization, all the modules are getting ready for Chandrayaan II launch during the window of 9th to 16 July 2019. The moon landing is likely to be around the 6th of September, nearly 2 months after the launch, close to the lunar South Pole. If successful, India will become only the 4th country in the world to land on the moon after Russia, the United States of America and China. Chandrayaan II was originally scheduled for launch in January this year, but due to multiple complexities in the mission, it was deferred to April. But now, with various tests completed and in the final stages, Chandrayaan II has got another launch window, that is in July. On the show today, we'll tell you all about India's ambitious second lunar mission, the various features of Chandrayaan II and what all it is likely to explore on its mission to the moon. Besides, we'll also talk about the achievements of the Chandrayaan I mission and India's highly successful space odyssey. Chandrayaan II is a fully indigenous mission that comprises 3 modules, an orbiter, a lander named Vikram and a rover named Pragyan. It will be launched on board a GSLV Mark III rocket, which is a 3-stage heavy lift launch vehicle designed to carry 4-ton class satellites into geosynchronous transfer orbit. Now, all 3 modules of Chandrayaan II, the orbiter, lander as well as rover, are getting ready for a July launch. The orbiter and lander modules will be interfaced mechanically and stacked together as an integrated module and accommodated inside the GSLV Mark III launch vehicle. The rover is housed inside the lander. The integrated module will reach the moon's orbit using orbiter propulsion module after its launch into Earth-bound orbit by GSLV Mark III. After the launch, it might take 35 to 45 days to reach the moon. And that's why the moon landing date is expected to be the 6th of September. Once Chandrayaan II reaches the lunar orbit, the lander, Vikram, will separate from the orbiter and soft land at the predetermined site close to the South Pole. The South Pole, till now, has not been explored by other countries. The rover will roll out for carrying out scientific experiments on the lunar surface. Instruments would also be mounted on the lander and orbiter for carrying out scientific experiments. After analyzing the content of the lunar surface, the rover will send data as well as images back to the Earth through the orbiter within 15 minutes. So altogether, there will be 13 payloads in the spacecraft, 3 payloads in rover Pragyan and 10 payloads in lander Vikram and orbiter.
Like Earth, moon also there is day and night. But the only difference is that in the moon, in a particular point, the day may last as long as 15 days. And the night may last as long as 15 days. So there is a 15-day long day and 15-day long night. So if I choose a given point and if assume that it's at night time, landing there is going to be of no use, right? Because there will be no light and we can't take any photograph. I mean, we can't do many other spectral studies, many studies we cannot do. So you need sunlight. I mean, so you want to land when the place where you want to land is facing daytime. So basically, if you are looking at mineralogy mapping, you are using a remote sensing method to say that in this particular part of a moon, perhaps there is iron. Let's say, for example, there is iron. But how do you know that it's actually iron? So you have something in remote sensing what is called as ground truthing. That is, you land in that place, check in few areas and find out whether your remote sensing data exactly matches with your interpretation. So your ground truth actually matches with your interpretation, then you make a generalization that in the rest of the moon also, it's hold good in the same way, right? So you need to have some kind of a ground truthing to ensure that our remote sensing is given as a right kind of detail. So that's what this is going to do. That's why you also have a rover.
According to news reports, the launch of Chandrayaan II was postponed further to July in the backdrop of Israel's unsuccessful attempt to land on Moon. Israel's Bereshit spacecraft crashed during lunar landing on 11th of April this year. So ISRO is cautious about Chandrayaan II, which is its first mission to land on any celestial body. In fact, the landing of the 3,290-kilogram Chandrayaan II spacecraft will be much more difficult than Israel's Bereshit. Bereshit tried to touch down on a plain of solidified lava known as the Sea of Serenity, which has a flattened surface and more exposure to the sun, while Chandrayaan II will explore the South Pole, so far an uncharted territory. Only China's Chang'e 4 spacecraft had recently, in January, landed on the Moon's far side, also known as the dark side, because it faces away from the Earth and is comparatively unknown.
One of the unique feature of this landing is India has been focusing on the South Pole on Moon. Whereas if you look at all the Apollo programs, or even the earlier Soviet programs, they have all landed on the equator of the Moon. So we are going to the pole, that is South Pole, where there is a huge belief that substantial amount of ice in the form of, in the shadow regions of craters of Moon are available. So if you really have a surface water, then it would be a good place if you want to do any activity on the surface of Moon.
And let's now talk about India's first lunar mission, Chandrayaan I. It carried 5 scientific payloads and also detected evidence of a hydrogen-oxygen chemical bond, the lunar water, and examined radioactive elements on the surface that reflected the presence of ice on Moon. It provided ISRO with a high-resolution map of the Moon's surface. The operations of Chandrayaan I were originally planned to last 2 years, but the controllers permanently lost communication with the spacecraft on 28th of August 2009. The mission, however, helped scientists determine 95% of their objectives by providing new insights in understanding the Moon's origin and evolution.
0 plus 1 plus 2
Chandrayaan
plus
1
3
was India's
plus 4
first lunar probe,
5 seconds.
launched successfully by the Indian Space Research Organisation on 22nd October 2008 from Satish Dhawan Space Centre in Sriharikota. It was an unmanned spacecraft weighing 1,380 kilos with onboard power of 700 watts, launched from PSLV C-11 launch vehicle. The satellite made more than 3,400 orbits around the Moon. The spacecraft carried 11 scientific payloads built in India, UK, USA, Germany, Bulgaria and Sweden. The mission comprised an orbiter and an impactor. The spacecraft was designed to study the Moon, including chemical, mineralogical and photogeologic mapping, orbiting around it at the height of 100 kilometers from the lunar surface. The mission provided a major boost to the Indian space program as India effectively researched and indigenously developed the technology to explore the Moon. The main objectives of the mission were to design, develop, launch and orbit a spacecraft around the Moon using an Indian-made launch vehicle, to conduct scientific experiments using instruments on the spacecraft which would yield results. Prepare a three-dimensional atlas of both the near and the far sides of the Moon, mapping chemical and mineralogical features of the entire lunar surface at high spatial resolution, mapping particularly the chemical elements magnesium, aluminum, silicon, calcium, iron, titanium, radon, uranium and thorium. Increase scientific knowledge. Test the impact of a sub-satellite on the surface of the Moon as a forerunner to the future soft landing missions. Detect water ice on the Moon.
The launch of Chandrayaan I was a feather in the cap of Indian space establishment, particularly because in the first attempt itself, Chandrayaan was launched successfully, and it also went around the Moon's orbit successfully. But then the real benefits came one after another. First of all, water was detected in the subsoil region. This was clear from the various instruments on board Chandrayaan I. And then Chandrayaan also, through its terrain mapper, it found out that there is one underground tunnel, what they call lava tube, which is about 1.7 kilometer long and 120 meters in diameter. And such lava tubes are going to be very, very useful when one wants to look for lunar colony establishment, because then you can have people staying inside that lava tube. You could have oxygen circulating, proper air conditioning, and sufficiently shielded from high energy particles.
Chandrayaan I detected evidence of water across the lunar surface. NASA's instrument, Moon Mineralogy Mapper, aboard Chandrayaan I helped to find the existence of water molecules on the lunar surface. Its findings also include confirmation of the magma ocean hypothesis, meaning the moon was once completely molten. Terrain mapping camera on board Chandrayaan I has recorded images of the landing site of US spacecraft Apollo 15. They have also enabled scientists to study interaction between the solar wind and a planetary body like Moon without a magnetic field. Chandrayaan I's X-ray spectrometer has detected titanium, confirmed the presence of calcium, and gathered the most accurate measurements yet of magnesium, aluminium, and iron on the lunar surface. India emerged as the fourth country in the world to hoist its flag on the lunar surface. After almost a year due to several technical issues and contact failure, on August 29, 2009, the ISRO officially declared the mission over. Chandrayaan I operated for 312 days against the planned 2 years, but was successful by achieving 95% of its planned objectives. Bureau Report, Rajya Sabha TV.
For the year 2019, the Indian Space Research Organization has planned 32 missions, some of which have successfully been launched. The ambitious second lunar mission, Chandrayaan II, will be launched in July, while the most awaited Gaganyaan mission will be launched in the year 2022.
To boost innovation and creativity and galvanize high-tech aerospace industry, ISRO has lined up many plans in the near future. It plans to send 2 unmanned missions to space in December 2020 and in
revolving around 100 kilometers away from the moon's surface and taking all the observations and the photographs. As far as Chandrayaan II mission is concerned, it will be consisting of 3 parts. One is an orbiter, rover and a lander. So rover and a lander system will be landing on the surface of the moon, and that is the critical aspect of it, that for the first time Indian made rover and a lander will be landing on the moon's surface.
India's second lunar mission will land a rover on the moon. Till now, only the US, Russia and China have been able to soft land spacecraft on the moon's surface. Under this lunar mission, ISRO will for the first time attempt to land a rover on the moon's south pole. The complex mission will comprise of an orbiter, lander and rover. The Chandrayaan II spacecraft will be launched by GSLV Mark II. The mission will encourage new experiments by the use and testing of new technologies. Chandrayaan II mission, costing nearly 800 crore rupees, is an advanced version of the previous Chandrayaan I mission that was launched about 10 years ago. India's maiden human spaceflight program Gaganyaan's activities would also go full steam to accomplish the various development and qualification milestones during this year. ISRO is preparing to send an astronaut into space in the year 2022 on board the Gaganyaan. Gaganyaan is an Indian crewed orbital spacecraft intended to be the basis of the Indian human spaceflight program. The spacecraft is being designed to carry 2 to 3 people. Gaganyaan will be launched on ISRO's biggest rocket, the GSLV Mark III, from Sriharikota. ISRO is also aiming to reinstate its microwave remote sensing capability through the radar image satellite series and attain operational geo-imaging capability through the GSAT or the Geo Imaging Satellite series. It is also planned to progressively improve the payload capability of GSLV and its variants. The country would meet the high output bandwidth requirement of Digital India and also in-flight connectivity with the launch of GSAT-20. On the application side, crop production estimation would be enhanced to cover 10 additional crops and also provide vital inputs for water and energy security. With inputs from Anu Diwan, Bureau Report for Rajya Sabha TV.
And let's now talk about India's space journey. It was on 21st of November 1963 that a small rocket took off from Tumba on the outskirts of Thiruvananthapuram, announcing the birth of the modern space age in India. Since then, India has crossed several milestones with its space program. Take a look at all the missions successfully launched by ISRO since its inception.
Space exploration in India began in 1960s. Dr. Vikram Sarabhai was a physicist and industrialist who initiated space research and helped develop nuclear power in India. He is also popularly known as the father of India's space program. Sarabhai was instrumental in establishing the Physical Research Laboratory in Ahmedabad after returning from Cambridge in 1947. India launched its first sounding rocket from Tumba near Thiruvananthapuram, Kerala on 21st November 1963, marking the beginning of the Indian space program. It was in 1962 that the Indian National Committee for Space Research was set up. It laid the foundation of Indian Space Research Organization in 1969. After setting up ISRO, the government constituted the Space Commission. It established the Department of Space in June 1972 and brought ISRO under the Department of Space in September 1972. India launched its first satellite Aryabhat in 1975 and then in 1979 Bhaskar 1 was launched. Aryabhat weighed 360 kilograms. On 10th August 1979, ISRO launched a series of satellites and named the mission Rohini. The Rohini series had 4 satellites, all launched by the Satellite Launch Vehicle, and 3 that made it successfully to the orbit. Then Aryan Passenger Payload Experiment or RAPPLE was ISRO's first indigenous experimental communication satellite. It was launched on June 19, 1981. ISRO took a huge step by developing telecommunication satellite. The Indian National Satellite or INSAT system is one of the largest domestic communication satellite systems in Asia-Pacific region with 9 operational communication satellites placed in geostationary orbit. It was commissioned in 1983. On August 30th, 1983, the INSAT-1B satellite was launched. Full operational capability was achieved in October 1983. Rakesh Sharma made history by becoming the first and only Indian to travel to space in a Soviet rocket that was launched on April 2, 1984. Then on 17th March 1988, ISRO launched its first remote sensing mission, IRS-1A. It was a part operational, part experimental mission to develop Indian expertise in satellite imagery. The first multi-purpose satellite, INSAT-2A, built by India, was successfully operationalized in August 1992. INSAT-2A-B of the INSAT-2 series of satellites was launched on July 23, 1993. These are all multi-purpose satellites for telecommunication. On 29 September 1997, ISRO launched its first fully operational satellite abroad, a locally developed rocket. India's Polar Satellite Launch Vehicle or PSLV slid into orbit an Earth imaging satellite after a textbook lift-off from Sriharikota Island. Kalpana 1 was the first dedicated meteorological satellite launched by ISRO using PSLV on September 12, 2002. Then ISRO launched GSAT-3, also known as EduSat, a communication satellite, on 20th September 2004. EduSat is the first Indian satellite built exclusively to serve educational sector. On December 22, 2005, ISRO successfully launched INSAT-4A from the European Ariane 5G launch vehicle of Arianespace. With 12 high-power Ku-band transponders, INSAT-4A was the first satellite to meet the requirement of direct-to-home television services apart from carrying 12 C-band transponders to augment the INSAT capacity for communication and TV services. And with successful launch of Chandrayaan I on October 22, 2008, ISRO's historic moon mission began. It was sent in space through PSLV C-11. ISRO had another major success on July 1, 2013, when it launched IR-NSS-1A navigation satellite. Along with this, India has stepped in to make its GPS system on the lines of America. It was on 5th November 2013 when India successfully launched its Mars Orbiter mission or Mangalyaan, a space probe orbiting Mars since 24 September 2014. The 350-ton Mangalyaan was scheduled to orbit Earth for nearly a month, building up the necessary velocity to break free from our planet's gravitational pull. The total cost of the project was 450 crore rupees, 1/6 of the cost of a Mars probe set to be launched by NASA in 13 days. IR-NSS-1I was the 8th navigation satellite to join the IR-NSS space segment launched by the ISRO in April 2018.
That Mangalyaan is one of the great achievement because at the cost it was launched and the way it was launched and in terms of the payload also, means the weight of the satellite and its capabilities. It is a big achievement and whole of the world is astonished because how India can launch such a large satellite at such a low cost.
On February 15, 2017, ISRO wrote a new chapter in the history of space research by creating a world record of launching 104 satellites simultaneously through PSLV C-37. It was the 38th successful mission of PSLV in a row. The total weight of all the 104 satellites carried on board PSLV C-37 was 1,378 kgs. PSLV C-37 blasted off first from the launch pad at the Satish Dhawan Space Center and first injected Carosat 2 series satellite into orbit, followed by the other 103 nanosatellites, including 96 from the US in a gap of about 30 minutes. The GSLV Mark III, the heaviest rocket ever made by India and capable of carrying large payloads, was launched from Sriharikota on June 5, 2017. GSLV Mk3 was designed to carry 4-ton class of satellites into geosynchronous transfer orbit, which is about twice the capacity of GSLV Mark II. At the same time, India has made its place in the field of space technology as the world's #1 leading nations. On June 29, 2017, ISRO launched GSAT-17, the heaviest satellite ever weighing 3,477 kgs. On January 12, 2018, ISRO successfully launched 31 satellites in a single flight. The PSLV carries 31 satellites in total from countries including India and 6 other countries. ISS weighing about 380 kgs was launched on November 29, 2018. It is an Earth observation satellite, primary goal to provide hyperspectral imaging services to India for a range of applications in agriculture, forestry as well as defense. On December 19, 2018, GSAT-7A was successfully launched. It is ISRO's 39th geostationary satellite carrying communication transponders. ISRO launched Kalamsat V2 on January 24, 2018. It is a communication satellite built by the students of Space Kids India for ham radio transmission, a form of wireless communication used by amateurs for non-commercial activities. ISRO successfully launched EMISAT satellite along with 28 satellites from Sriharikota on 1st April 2019. Bureau Report, Rajya Sabha TV.
And that's it from us in this edition of In Depth. You can also watch our program online on YouTube and Twitter. And don't forget to send your feedback and suggestions about our program. Thank you very much for watching.